Prove that if r is any rational number, then 5r squared minus 4r plus 1 is rational. As we talked about before, a rational number can be described as a over b, because a rational number is a fraction. So the first thing, we're going to rewrite r in the fractional form. So let r be equal to a over b. Let's specify a and b are integers and b is not 0. Well, because r, we know it's a rational number, but we don't know which rational number. Actually, it could be any. This works for any rational number. And in order to show 5r squared minus 4r plus 1 is rational, we need to show this can be written as a fraction. So if we want to describe r, we describe it as a over b, and we can now plug into the expression. So 5 is replace r with the fractional form a over b minus 4 times a over b plus 1. So here this part is algebra. So if we do exponent first, so we square the top, square the bottom, and then we multiply. We put a 4 as 4 over 1. So to multiply fractions, we multiply straight across. So 4 times a is 4a, 1 times b is b. And we're going to write 1 as, also as a fractional form. So that would be 1 over 1. And over here we can do the same thing. Multiply 5 and a squared. We get 5a squared over 1 times b squared. That's b squared. So minus 4a over b plus 1 over 1. So now we got to add these three fractions. And first, find LCD, the least common denominator. So we know 1b, b squared, they all go into b squared. So that makes b squared LCD. So we're going to try to get a common denominator, b squared. So the first one is already b squared, leave it alone. We multiply the second fraction by b, both top and bottom, so we can get b squared on the bottom. And the second one, we need to multiply both the top and the bottom by b squared in order to get b squared. So now we have, see, b times b is b squared, 1 times b squared is b squared. So we're going to get a common denominator b squared, and so we can add a numerator or subtract the numerators. So we're going to do 5a squared minus 4ab plus b squared. So that's on the top. So once we get the common denominator, we can just subtract or add numerators. Now we can look at the final answer, the simplified form. That's apparently a fractional form. All we have to verify now is the top and the bottom, make sure they're both integers. And apparently, since a, b are integers, and we're going to have 5a squared minus 4ab plus b squared. That's the top, is an integer, and bottom b squared is integer, because when we multiply integers, square integers, add, subtract integers, we still get integers. So we can say, 5r squared minus 4ab plus b squared over b squared. This is obtained. This is simplified form for 5r squared minus 4r plus 1 is rational because it's a fraction. So in this proof uses the general form of a fraction a over b, and so it doesn't matter what kind of fraction it is. Doesn't matter what a is, what b is, and we can verify 5r squared minus 4r plus 1 is going to be a fraction.